The directions say to solve the ordinary differential equation by undetermined coefficients. Let's take a look at example 1. Suppose we are given y double prime plus 3y prime plus 2y equals 6. In the first step, we want to solve the associated homogeneous equation y double prime plus 3y prime plus 2y equals 0 to find the complementary solution y sub c. So, set y equal to e to the rx, y prime is r e to the rx, and y double prime is r squared e to the rx. Remember that e to the rx is never 0. So when I make my substitution and divide through by e to the rx, we get the following. We get r squared plus 3r plus 2 equals 0. So r plus 1 times r plus 2 equals 0, r equals -1, or r equals -2. And remember the goal, when we solve this associated homogeneous differential equation, we are looking for two linearly independent solutions first. And those linearly independent solutions are the following. It's y1 equals e to the -1x, and y2 equals e to the -2x. And so my complementary solution y sub c is equal to ae to the -x plus be to the -2x. In the second step, we want to find a particular solution y sub p to y double prime plus 3y prime plus 2y equals 6. Since g of x is equal to 6, let's try y sub p is equal to k. So y sub p prime is equal to 0, and y sub p double prime is equal to 0. So remember, k is constant. Now, by design, y sub p double prime plus 3y sub p prime plus 2y sub p is equal to 6. Making my substitution, I get 2k equals 6. Dividing through by 2, I get k equals 3. Now, my general solution, y, is equal to y sub c plus y sub p. So it's the complementary solution plus the particular solution. So putting that all together, I get y equals ae to the -x plus be to the -2x plus 3. In example 2, we have y double prime minus 10y prime plus 25y equals 30x plus 3. In the first step, we want to solve the associated homogeneous equation y double prime minus 10y prime plus 25y equals 0 to find the complementary solution y sub c. So just like in the first example, I'm going to set y equal to e to the rx. Y prime is re to the rx, and y double prime is r squared e to the rx. And again, remember, e to the rx is never 0. So when I make my substitution and divide through by e to the rx, I get the following. I get r squared minus 10r plus 25 is equal to 0. So that means r minus 5 to the second is equal to 0. Solving for r, remember we want two solutions. I would write r equals 5 twice. Okay. Now, my linearly independent solutions I claim are y1, which is equal to e to the 5x, and y2, which is equal to x e to the 5x. And we can show that y1 and y2 are linearly independent. And so my complementary solution y sub c is equal to ae to the 5x plus bxe to the 5x. In the second step, we want to find a particular solution y sub p to y double prime minus 10y prime plus 25y equals 30x plus 3. Since g of x is equal to 30x plus 3, let's try y sub p is equal to ax plus b. So that says y sub p prime is equal to a, and y sub p double prime is equal to 0. Now remember, by design, y sub p double prime minus 10y sub p prime plus 25y sub p is equal to 30x plus 3. Now, let's make our substitution. Now, I'm going to replace y sub p prime with a. So I get negative 10a plus 25 times the quantity ax plus b. So you notice I replaced y sub p with ax plus b. And that's equal to 30x plus 3. So I'm going to distribute the 25 inside. And when I do, I get negative 10a plus 25ax plus 25b is equal to 30x plus 3. And so what that says is 25a has to equal 30. There's no choice. And then negative 10a plus 25b is equal to 3. If I solve for a and b, I claim a is equal to 6 over 5 and b is equal to 3 over 5. So my y sub p, in other words, my particular solution, is 6/5 x plus 3 over 5. Now I get to put it together. So my general solution y is ae to the negative 5x plus bxe to the negative 5x plus 6/5 x plus 3/5. So you notice my first two terms belong to the complementary solution, and the second two terms is the particular solution, and I'm putting it together. So that's my general solution to this differential equation. And that's example 2. In example 3, we have 1/4 y double prime plus y prime plus y equals x squared minus 2x. In the first step, we want to solve 1/4 y double prime plus y equal to 0 to find my complementary solution y sub c. So in other words, we want to solve the associated homogeneous equation to find the complementary solution y sub c. So I'm going to set y equal to e to the rx. Y prime is re to the rx, and y double prime is r squared e to the rx. Now, just like in the first two examples, remember e to the rx is never 0. So when I make my substitution and divide through by e to the rx, I get 1/4 r squared plus r plus 1 equals 0. Multiply both sides by 4, and we get r squared plus 4r plus 4 equals 0. Solving for r, I get r equals negative 2 twice. So my complementary solution is y sub c is ae to the negative 2x plus bxe to the negative 2x. In the second step, we want to find a particular solution y sub p to 1/4 y double prime plus y equals x squared minus 2x. Since g of x is x squared minus 2x, let's try y sub p equal to ax squared plus bx plus c. So my first derivative, y sub p prime, is equal to 2ax plus b. Y sub p double prime is equal to 2a. Now, we're going to go ahead and make our substitution into this differential equation up here. And when we do, we get 1/4 times 2a plus 2ax plus b plus ax squared plus bx plus c is equal to x squared minus 2x. Now, I want you to notice what I did. I grouped things accordingly. So I'm going to group the constants. So I get 1/2 a plus b plus c. And then I grouped the terms that contain a factor of x and then factored out the x. So then I'm going to add 2a plus b, that quantity times x, plus ax squared. And then on the other side, I get x squared minus 2x. So that automatically, that says a equals 1. And then 2a plus b equals negative 2. And 1/2 a plus b plus c equals 1. And you notice I solved for b and I got b equals negative 4. And then I solved for c and got c equal to 9/2. So putting everything together, I get y equals ae to the negative 2x plus bx e to the negative 2x. That's my complementary. And then plus x squared minus 4x plus 9/2. And so those last three terms are my particular solution. And if you're more comfortable, we can come over here and we can write y sub p is equal to x squared minus 4x plus 9/2. So you could write the particular solution first, and then from here, put everything together. And that might make it a bit easier. Example 4 is a very, very interesting problem that I definitely need to take you through. Suppose we are given y double prime minus 16y equals 2e to the 4x. This is a great question. In the first step, we want to solve the associated homogeneous equation y double prime minus 16y equals 0 to find y sub c. Set y equal to e to the rx, y prime is re to the rx, and y double prime is r squared e to the rx. So now, again, just like before, let's make sure we understand. E to the rx is never 0. And so I'm going to make my substitution into this homogeneous equation, right? And divide through by e to the rx. And that's where I'm getting r squared minus 16 equals 0. Solving for r, I get r equals plus or minus 4. So my complementary solution is equal to ae to the 4x plus be to the negative 4x. So in other words, y sub c is ae to the 4x plus be to the negative 4x. In the second step, we want to find a particular solution y sub p to y double prime minus 16y equal to 2e to the 4x. Well, let's try y sub p equals ae to the 4x. Now, let's take the first and second derivative. So y sub p prime is 4a e to the 4x, and y sub p double prime is 16a e to the 4x. So remember, y sub p double prime minus 16y sub p is equal to 2e to the 4x. If I make my substitution, I get 16a e to the 4x minus 16a e to the 4x, and that is equal to 2e to the 4x. What that tells me is 2e to the 4x is equal to 0. That's a problem. That's a contradiction, because remember, e to the 4x is never 0. Now, you might ask, why did I get a contradiction? The reason why I got a contradiction is because 2e to the 4x, this term here, in fact, let me do better. Let's come up here. If we look at y sub p equal to e to the 4x, and then look at the complementary solution. So my particular solution was part of the complementary solution. Does that make sense? And your particular solution cannot be a part of the complementary solution. So they have to be distinct. Now the question becomes, how do I make that distinct? And what we're going to do is the following. We're going to try y sub p is equal to ax e to the 4x. So you're going to multiply by an x. And if we take the first and second derivative, we get y sub p prime is equal to ae to the 4x plus 4ax e to the 4x. That's just product rule. And then y sub p double prime, I claim, is 8a e to the 4x plus 16ax e to the 4x. So remember, by design, y sub p double prime minus 16y sub p is equal to 2e to the 4x. If I make my substitution and solve, I get 8a e to the 4x plus 16ax e to the 4x minus 16ax e to the 4x is equal to 2e to the 4x. So notice how these two terms are going to cancel. And we get 8a e to the 4x is equal to 2e to the 4x. But that tells me 8a equals 2. That tells me a equals 1/4. And so my particular solution, y sub p, is 1/4 x e to the 4x. That's what that means. So that allowed me to find a particular solution to this differential equation. And so when I put it together, my general solution is y equals ae to the 4x plus be to the negative 4x plus 1/4 x e to the 4x. And that's example 4. Let's take a look at example 5. Suppose I have y triple prime minus 6y double prime is equal to 3 minus cosine x. First, I want to solve y triple prime minus 6y double prime equals 0 to find the complementary solution y sub c. Set y equal to e to the rx. Y prime is r e to the rx. Y double prime is r squared e to the rx. Y triple prime is r cubed e to the rx. And like in the last 4 examples, e to the rx is never 0. So when I make my substitution and divide through by e to the rx, I get r cubed minus 6r squared equals 0. Factor out an r squared, and so when I do, I get r squared times r minus 6 equals 0. Solving for r, I get r equals 0 twice, or r equals 6. So I claim that my complementary solution will be y sub c is equal to a plus bx plus ce to the 6x. In the second step, I want to find a particular solution y sub p to y triple prime minus 6y double prime equals 3 minus cosine x. Well, this is what I'm going to do. I'm going to try y sub p is equal to ax squared plus b cosine x plus c sine x. And notice I take the first, second, and third derivative accordingly. Now, you might ask, before we go further, why do I have ax squared here? Okay, because if we go back, notice that's a 3. Why didn't I just put a? The reason why I didn't put a is because a is part of the complementary solution. And then you might ask, well, why didn't I put ax? Because ax is part of the complementary solution. Yeah, that's a b, right? But if you take a constant multiple of x, that is part of the complementary solution. And so that's why I call it ax squared. So I had to multiply, in other words, by another x. And that's why we have y sub p is ax squared plus b cosine x plus c sine x. So I take the first, second, and third derivatives, and by design, y sub p triple prime minus 6y sub p double prime is equal to 3 minus cosine x. I go ahead and make my substitution, and I get b sine x minus c cosine x minus 6 times the quantity, 2a minus b cosine x minus c sine x is equal to 3 minus cosine x. So it's pretty involved. And my goal is to solve for a, b, and c. Well, when I solve for a, I ended up getting a equals negative 1/4. If I solve for b and c, I ended up getting c equals 1/37 and b equals negative 6/37. And so if I put it all together, I get y equals a plus bx plus ce to the 6x. That's my complementary. And then my particular will be negative 1/4 x squared minus 6/37 cosine x plus 1/37 sine of x. And that's how we solve example 5. And that'll do it for this video. This is a video on undetermined coefficients. So most of my examples were second order differential equations that I solved by undetermined coefficients. And the fifth example was a third order differential equation solved by the same method. So, okay, thank you.